All right, De Morgan's law. De Morgan's law says that not P union Q is the same as not P intersection with not Q. Is that true? Let's find out. P union Q are these values right here. Then what is not P union Q? Well, that's everything else. From our sets, what we're looking at is just 3. You should remember that in truth we're talking about the universal set, so everything outside of this is included. But to make things simpler, we're just going to focus on the sets that we're looking at. So we're looking at 3. That is what this defines. What about not P? What is not P? Well, not P is, for our purposes, this, right? Then what is not Q? Not Q is this right here. What is the intersection of not P and not Q? And that's going to be, you can't see it, but that's a 3, right? So 3 is the answer for both of them. They are equivalent. Now, if we're truly talking about this set, remember, we would also be including everything outside of the 3 sets that we defined, but that just makes things more complicated. The key thing is De Morgan's law is true, right? Those 2 sets are equivalent. They describe the exact same values, all right? Let's go on to the next rule. All right, so the absorption rule says that P union with P intersection Q equals P. Is that true? Well, let's take a look. P intersection Q is going to be this right here, right? And then P union with that is going to include 4, which is P. So the absorption rule is also true. And finally, we have the commutative rule, which is, I think, commutative rule is pretty basic. It says that P intersection Q is the same as Q intersection P, right? Which makes sense. I don't think anybody would argue with any of that. P intersection Q is going to be 687. Q intersection P is also going to be 687. The ordering doesn't matter. It's a very simple rule, but it's a very important rule, right? That's what allows us to reposition things so that they're next to each other, so that we can use De Morgan's law, idempotency, double negative, all that fun stuff. All right. So that is the algebraic theorems of sets, along with the example 1. Which kind of proves that they are true intuitively. This is a really good set, this QPR, and you should kind of write this out and keep it. There are 2 things that you should have next to you every time you're working with sets. 1, you should have that list of rules, right? Those algebraic rules, which are the same algebraic rules that we used for Boolean functions. The exact same rules. You should have that just kind of next to you whenever you're doing anything. I would also keep this Venn diagram. This is a great Venn diagram. It is a really useful Venn diagram to have handy with these values to just kind of test out, what is P minus R, what is Q minus P intersection R. You can really see visually what's going on with sets through examples you can create with this for pretty much anything that you want to do. If you have any questions, ask in the forum below, and let's move on to, whatever's next in set theory.